But some of you are among the best scientists in the world. And what you and your colleagues have been showing us for years now is that human activities are changing the climate in dangerous ways. Levels of carbon dioxide, which heats up our atmosphere, are higher than they've been in 800,000 years. 2014 was the planet's warmest year on record, and we've been setting a lot of records in terms of warmest years over the last decade. One year doesn't make a trend, but 14 of the 15 warmest years on record have fallen within the first 15 years of this century. Climate change is no longer just about the future that we're predicting for our children or our grandchildren. It's about the reality that we're living with every day, right now. The Pentagon says that climate change poses immediate risks to our national security. While we can't say any single weather event is entirely caused by climate change, we've seen stronger storms, deeper droughts, longer wildfire seasons. Charleston and Miami now flood at high tide. Shrinking ice caps forced National Geographic to make the biggest change in its atlas since the Soviet Union broke apart. Over the past 3 decades, nationwide asthma rates have more than doubled. And climate change puts those Americans at greater risk of landing in the hospital. As one of America's governors has said, we're the first generation to feel the impact of climate change and the last generation that can do something about it. And that's why I committed the United States to leading the world on this challenge, because I believe there is such a thing as being too late. Most of the issues that I deal with, and I deal with some tough issues that cross my desk. By definition, I don't deal with issues if they're easy to solve because somebody else has already solved them. And some of them are grim. Some of them are heartbreaking. Some of them are hard. Some of them are frustrating. But most of the time, the issues we deal with are ones that are temporally bound, and we can anticipate things getting better if we just kind of plug away at it, even incrementally. But this is one of those rare issues, because of its magnitude, because of its scope, that if we don't get it right, we may not be able to reverse. And we may not be able to adapt sufficiently. There is such a thing as being too late when it comes to climate change.
But to be absolutely honest, the whole area, the whole of the eastern United States is going to be affected to some extent. So it does rely on knowing or getting some idea when this collapse is going to occur and really moving people out. Something has to be done if you're going to reduce what would otherwise be an enormous death toll.
Although this is one of nature's most devastating phenomena, mankind is helping the process along because of pollution.
The key thing is that we found that to get rain into the centre of the island, you need very warm sea surface temperatures. Because at the moment, if you go to the Canary Islands, it's very dry on the beaches, you go up the hill, beautiful rainforest, and in the centre is desert. Now, if you heat up the oceans, and we've seen this in the past, the actual cloud layer and the heat exported rises, and then it will float much higher over the island, causing rain to actually fall into the centre. We have evidence that global warming is causing sea surface temperature to rise. But we also have evidence from around the world that that cloud layer is actually rising.
Planetary temperature increases are not only melting the polar ice caps, but could be leading to Earth's worst natural disaster.
Global warming could actually put water into the centre of the volcano and mean that we have a precursor, and next eruption could cause it to fail.
In terms of what do I think is going to be the next global natural catastrophe, I'd put the collapse of La Palma top of the list. Well, it started to slide in 1949. It's something that's happening. It's ongoing. It's not something we're waiting to happen. It started in 1949. It looks as if it might be sliding still about a centimetre a year. All we're waiting for is a final crash into the sea.
These collapses are more likely to occur at present than on the long-term average. And there are a number of volcanoes that we're concerned about that are showing signs of precursory instability and that may be particularly likely to collapse during an eruption in the near future.
The #1 cause of tsunamis is undersea earthquakes. That's what triggered the massive waves in the Indian Ocean in 2004. The seafloor ruptured suddenly, thrusting one plate upward and producing a huge bulge on the water's surface.
As the seafloor lifted, it displaced billions of tons of water above it in a process called tsunami initiation. This released as much energy as 23,000 Hiroshima-sized atom bombs.
As a result of the earthquake, part of the ocean floor has been uplifted and part has been dropped down along the fault surface. Because the seafloor changes, so does the water column above the seafloor. So some parts go up here, some parts go down.
Seconds later, the tsunami undergoes a transformation as the displaced water column splits.
The uplifted area basically collapses and the water rushes away from the uplifted area, creating a tsunami wave that's traveling radially away from the uplifted area. The tsunami wave's now speeding off to some distant shore at 1,000 kilometers per hour.
The main pulse can cover the ocean quite rapidly, which means that in the initial few minutes, the northwest part of Sumatra would have been hit.
In Sumatra, 10 minutes after the earthquake, people are unaware that an enormous wave is charging toward them at over 500 miles an hour. In the open ocean, tsunamis are virtually undetectable. This simulation shows how a boat in deep water is only slightly affected. Fishermen at sea barely notice a tsunami passing under their boat. But as a tsunami nears land, it rears up into a monster, growing by a process called amplification.
As the wave approaches the land, the front of the wave slows down. It slows down to 400, 300, 200 miles an hour. The back of the wave is still going at 500 miles an hour. And the back of the wave catches up with the front. And you get this big buildup of water.
The amplifying wave can have a curious side effect. Before hitting land, it draws water from the leading edge, exposing the seafloor for as much as a mile. This phenomenon would lure thousands to their deaths.
One of the big problems about trying to prevent deaths due to tsunami is trying to stop people rushing down to the beach when the sea goes out. That happened here. People went down, they saw fish flapping about on the beach, went down to pick them up.
If you see the sea start to go out, you don't stand and wash in awe, you run.